Okay guys, I gotta warn you with this video, it is after midnight right now when I'm making it. I'm tired and I cannot be held responsible if I make some mistakes. You'll just have to let me know tomorrow. In this video we're going to talk about what is a theorem, and we're actually going to prove a couple of them. We've been kind of throwing the word theorem around a lot, but we've never really said what it is, so let's get it out in the open. When we give a statement the title of theorem, it's because it has been or can be proven true. So probably the most famous theorem is the Pythagorean theorem. And there's other theorems like Pick's theorem and the congruent supplements theorem that we're going to see in this lesson. Pretty much if you come up with a proof for a good theorem, you get to name it whatever you want. And a lot of people will name it after themselves, like Pythagorean theorem or Pick's theorem. If you get really good at proof, you can prove some of the conjectures, those millennium problems that are worth, what, $1 million did they say in that video? So that could be worth it. Just remember who taught you proof when you get that $1 million. So in this one we're going to learn about 3 theorems and we're going to prove them also. The first one is the congruent supplements theorem. And it says if 2 angles are each supplements of a third angle, then they are going to be congruent to each other. So you can see in this picture we're going to say that angle 1 and angle 2, those are supplements. That's a given. They're supplementary angles. And also we see angle 3 and angle 2. Angle 3 and angle 2 are also supplementary. And our job here is to prove that angle 1 must logically be congruent to angle 3. I hope you believe that. Take a look at that and read it again if you're not sure. Angle 1 and 2 add to 180. Angle 2 and 3 add to 180. So angle 1 has to be the same as angle 3, congruent to it. So let's start with our first statements. First statement, like we have been seeing before, is the given. So we are given that angle 1 and 2 are supplementary and angle 3 and 2 are supplementary. Okay, stop now and think about what does that word mean. This is going to be a definition in our next line. What does the word supplementary mean? You remember they add to what number? Supplementary means they add to 180. Angle 1 and angle 2 add to 180. And angle 3 and angle 2 add to 180. We're just applying the definition of the word supplementary. So in our reason, we're going to use definition of supplementary. Okay, now what we've got here is a set of angles. Both angles are equal to the same number. They both equal 180 in total. So since they both equal the same number, we might be able to change some things around. And in fact, that's what our next line is going to say. We're going to say that angle 1 and angle 2 are the same total as angle 3 and angle 2 because they both added to 180 here. Now, there's 2 different reasons you could put that would make sense here. That sounds to me a lot like the transitive property. When 2 things are both equal to the same thing, that's the transitive property. But you also could just call that substitution. We're taking the 180 out and we're replacing it with this set of angles here. So either substitution or the transitive property would be an appropriate reason for this. I'm just going to abbreviate transitive property. Now you don't have to put them both, but you can have either one. All right, let's look at what our equation looks like now. I'm noticing that, oh yeah, the same thing again has appeared on both sides of this equation. You guys see angle 2 here on the right, or on the left? See, it's after midnight. And you got angle 2 on the other side. So if angle 2 appears on both sides, does that allow us to get rid of it? Let's subtract it from both sides, and then we'll just have angle 1 and angle 3 left on each side. Angle 1 and angle 3, those measures are equal. And what did we do to get rid of that angle 2? We applied the subtraction property. All right, now I thought we were done, but no, we got to look again. Up in the problem, it said we had to prove they were congruent. Right now we've only proven they're equal. So if the measures are equal, then it follows that the angles are congruent. The definition of congruent is what we just applied there. So if you've got 2 angles that both are going to add up to 180 when they add to a different angle, they're going to be equal to each other, that total. Congratulations, you just proved your first theorem that has a name, the congruent supplements theorem. Now take a look at the congruent complements theorem. It's going to have a similar flavor to it. If 2 angles are each complements of a third angle, then they're congruent to each other, just like the congruent supplements. So here's our diagram. 1 and 2 are given to be complementary, and 2 and 3 are given to be complementary. So again, we're going to prove that angle 1 is congruent to angle 3. Now I want you to pause the video. I'm going to take these boxes away, but you pause the video. See if you can write the whole proof from beginning to end, and then come back and check with mine. Okay, we're back. I am going to delete these boxes. Let's see how you did. Okay, how does it look? Did you say that 1 and 2 are complementary and 3 and 2 are complementary because they're given? In the next line, maybe you wrote angle 1 and angle 2 add to 90. Angle 3 and angle 2 add to 90 because that's our definition of complementary. Complementary angles add to 90. Again, we saw that we already stated up here they were complementary, so that allowed us to use the definition of complementary as a reason. All right, if they both added to 90, did you set those two parts equal to each other using substitution? Or again, you could have said transitive property right there. And then did you take away your angle 2's? Angle 2's both leave this problem on both sides using subtraction property, subtracting from both sides. And then let's convert that equals into a congruent symbol as the definition of congruent, which justifies that. Okay, the last theorem for this lesson is called the vertical angles theorem. And the vertical angles theorem is a big one. You're going to use this thing all the time. So you need to recognize when you see vertical angles that they are congruent. We've already used it actually in chapter 1. Let's prove it though. We've never proven it. We just said, yeah, that is true, but let's prove it's true. How do we know? So we're given intersecting lines M and N. Remember, vertical angles are formed when two intersecting lines cross to make an X. And we have to prove that angle 1 and angle 3 are congruent. That's our job. Now, the same thing could apply to angle 2 and angle 4, but we're just going to talk about angle 1 and angle 3. So this is a pretty short proof, as you can see, but only because we already laid some groundwork. I want you to remember that when you prove a theorem, it's a true statement, which means you're allowed to use theorems in proofs as well. So you're going to see that happen here. We're going to start out with our givens. We're given these two intersecting lines, line M and line N. Well, lines make angles when they intersect, and some of the angles they make are called linear pairs. Where's the linear pair in here? Let's find a linear pair with angle 1. I'm going to say angle 1 and angle 2 are a linear pair. And what other linear pair can I find? Well, I could find angle 1 and 4 or angle 3 and 4, any of these next door neighbor angles. But I'm going to take angle 3 and angle 2. And I'm going to say that those are two sets of linear pairs. So that's my next statement. Angle 1 and angle 2 are a linear pair. They're supplementary. They add to 180 because they're on the straight line. And 3 and 2 also are supplementary because they're on the straight line. And I know they are because I was given lines. So that's a definition of linear pair. Well, if 1 is supplementary to 2 and 3 is also supplementary to 2, we just proved a theorem that said that 1 and 3 would be congruent. Look back in your notes. It's in this very lesson. 1 supplements 2 and 3 also supplements 2. So that would mean automatically 1 and 3 must be congruent. What was the name of the theorem that said that? We just saw it. That was the congruent supplements theorem. When two angles are both supplements to the same angle, in this case 1 and 3 are both supplements to angle 2, then they are congruent to each other. And so we're done. We've proven the vertical angles theorem, and now we can use it with confidence that we are doing the right thing. Always do the right thing. Now I'm going to bed. Good night.